A very pleasant good morning, everyone. I would like to start by wishing you and your families my personal best for your health and safety. Thank you for being with us today. From our oldest participants who have been diligently supporting us since the beginning, as well as every new face to our AABN's 174th weekly webinar, we extend a very warm welcome. On behalf of the core committee team, I sincerely thank and acknowledge everyone of you who have extended help to us for making these events a grand success. Trust us, all of this would have been just a dream if not for your immense support. Today, I would like to point your attention to our fresh faces. You are here today because we are asking for your support to AABN. We grow and scale successfully only with your dedication towards individual and group goals. You are an integral part of our success story, and we need you as much as you need us. Over the past 4 years, we have been able to put together online programs to keep our AABN community not just engaged, but also meet a range of inspirations who can help shape your ideas and thoughts. Today, we have one such personality, Mr. Subin Joseph, a respected professional in the AA industry. What makes him an apt choice for this audience is that he too is an alumnus of phenomenal university, and he belongs to 1990 batch of electrical and electronics engineering. To me, Subin is an old pal. Our days at the hostel and on campus were filled with some tragic comedy moments, which we continue to cherish for a lifetime. Our time on the basketball court was filled with laughter that rings in my head even today. The manufacturing industry has always been a sector that thrives on innovation and technology. One of the latest advancements that have revolutionized is the implementation of AI-driven quality control in manufacturing. Quality control is an integral component of the manufacturing process. It ensures that the products produced meet the expected standards and requirements, contributing to customer satisfaction and loyalty. However, traditional manual inspections can be time-consuming, costly, and prone to human error. With the rise of complex manufacturing process and the demand for high-quality products, the need for more efficient and accurate quality control methods has become apparent. This is where AI-driven quality control steps in, offering a more effective solution for maintaining product quality. I have the pleasant duty of welcoming and introducing Mr. Subin Joseph today at Intelligent Manufacturing, Harnessing AI for Quality Control Excellence, an interactive business networking session. Subin leads the sales and marketing functions for Centre, an AI machine vision company with focus on the manufacturing segment. In this role, he leverages his deep go-to-market expertise to scale Sencore's growth plans globally. Subin has more than 3 decades of experience in the information technology industry with a strong proven track record in sales, product management, and business management. Prior to his current role, Subin was a global vice president at HP Inc. In a 26-year career with HP, he has also led businesses at an Asia-Pacific level and was also the managing director for HP in Indonesia. Subin is an alumnus of Annamalai University, India, where he graduated with a bachelor's degree in electrical and electronics engineering, and he also has a diploma in digital transformation from Yale University. On the personal side, the university circles remember Subin Joseph for his warmth, love for sports, and his genuine value for friendship. An avid reader and as someone who performs in pressure situations, he is here to regale us with all his assured experiences. He is also an impactful motivator of his team. Those who know him say his enthusiasm is infectious, and we are lucky to experience it up close today. Thank you, and over to you, Subin.
Thank you very much, Gopi. Gopi, I want a recording of this because I want to play it back to everybody. I don't think anybody could have given me a better introduction. Thank you for that. So a very big thank you to AABN for giving me this opportunity. As Gopi mentioned, I've spent about 30 years in the information technology industry, and my focus was basically on the hardware side of things. And this is a late career switch. An old dog wanted to learn new tricks. Working in the AI space has tremendously accelerated my learning, and including my appreciation for how technology can really help transform lives. Now, I don't know how many of you are, everybody knows about AI, but I don't know the depth of familiarity that everyone on this session has with AI, and what's the familiarity with quality inspection or machine vision. For some, it could be something they know well. For others, it could be something is a new topic. There are parts where I will go a little basic to start out with so that we just get everybody grounded. So for those who are familiar with it, please be patient. We will get to the meat of things very quickly. So I joined Senquire about 4 to 5 months back, and I've been really blessed to be part of a brilliant team of geeks, if I may say so. They absolutely know what they're doing around AI and what they do around machine vision, as well as quality inspection is just amazing. The program is not so much to plug Senquire, though you will see a lot of the slides that I use are of Senquire origin. It is basically to talk about the impact that AI is having in quality inspection. Before I switch slides and get into the topic, I do want to put a caveat out there. I'm not a quality inspection expert. QC is not my domain. I'm sales and marketing. But I will tell you as much as I have learned and know about this field, and I would definitely welcome feedback and input from each one of you here. Okay, so let's get into it. I'm going to very briefly cover AI at a very basic level, just to set stage. I'm going to talk about AI with specific reference to machine vision and the ability of AI to inspect. I'm going to compare also a little bit to other vision solutions that were there before AI came, what were the issues, and how AI can help quality inspection and control just leapfrog tremendously. I'm also going to talk about different models and approaches that are there. I'll touch upon what the overall ecosystem would look like in a manufacturing setup. Then I'll get into specific use cases, and there I hope really interest you in terms of the sheer ability that we now have on quality inspection. Last, we can actually either get into benefits of AI, but I think by then we probably will be up on time and we can get into any last-minute Q&A. Okay, so let me get started, right? AI is a huge topic. There are many different parts of artificial intelligence which are applicable to different scenarios, industry sectors, use cases. But with the specific context of machine vision and quality inspection, I'm going to touch upon 5 major components, which are also the core among the core components of AI, which is around, machine learning, right? So machine learning really is a set of algorithms and statistical models that try to mimic the human brain. And through that process, what they absolutely do is that they are able to deduce a lot more in terms of deduce and predict a lot more in terms of outcomes. Deep learning is a subset of machine learning. These are really neural networks, multi-layered neural networks that are there where an information, object, an image, or series of data, it goes through these layers. And in each of these layers, it either goes through convolution or it goes through a complete rebuild. Deep learning actually works best when there is vast amounts of data available from which the AI model is able to learn effectively, and then it get really good in terms of what kind of what it generates as an outcome. NLP is also an important part of AI, and it's also relevant to machine vision inspection because a lot of the inspection that is done is related to character recognition and the ability to read characters and letters, no matter how they are presented. I'll later show some extremely challenging but innovative ways in which NLP is being used. Robotics, of course, is the next leg of any automated manufacturing setup, and particularly so when we are using AI, because what the field of robotics does for us is that it enables a robot to do the same actions and tasks as a human being, but do it very consistently and mostly flawlessly. Robotics is really important because with AI, now the robotic field is able to perceive the environment around it and, if necessary, take adaptive action. Last but not the least in this whole topic is computer vision. Um, Computer vision has been around for a while, but what AI has done is that it's been able to take the same image or video that comes to computer vision and extrapolate that into a capability that's very much like a human being is able to take an entire image and look at it pixel by pixel and look at variations in those pixels to be able to interpret. I'll explain this a little more later when I explain the difference between what traditional vision was doing, what AI-led vision is doing. So typically, a machine vision company, and I'll show you the ecosystem in a short while, and then we can pause for questions also there. Basically, we use different forms of models, or models as they're called. There are many different types of models available, but typically for image processing, the most popular ones are called the convolutional neural networks. And there have been many advancements and variations of these neural networks. Different people, different researchers look at it and see how to make it even more effective than it is. What you see on your screen here is a simple image of a car. And what it's showing here is a three-quarter view of the car. And the reason why we're I'm showing a car is because it's a significantly large object, but it also has got very specific features, including mirrors, tires have rims. There is the warning lights in the back. There is a number plate. And when a convolutional neural network looks at this image, it doesn't take the image as is. It actually breaks the image down to very specific features. And it puts it through convolutions as well as other processes till the final convolution or the final composite is created. What it basically does is that it takes a series of look at it and starts blurring out different parts of the image and focusing on different features. And then it puts it through a neural network. And this network then puts it all together back again and finally has what is called the predicted image. Now, why is this important? When you look at a car, you can have a 370-degree view from many different parts of the car. I mean, from 360 degrees, you can have not 370, actually 270. You can have different views of a car. At the end of the day, whether it's a car, a bolt, a screw, a clutch plate, a wafer, the image has to be put back together, and it has to be put back together accurately. And from that big image, with so many pixels, it has to be able to pick up specific features that are there, right? So in this car, for example, the number plate recognition would be a feature. So every car passing by, first of all, to classify it as a car and then to read the number plate, that's a feature. And irrespective of which angle it sees it, whether it's seeing it from left, right, or from the center, it has to be able to do that. So there are many such models available, and different use cases require different models for image translation and feature recognition, as well as being able to predict. Typically, the RCNN, or region-based convoluted neural network, is the one that's most used. I will not get into more specifics on this. I'm just trying to give you a sense that today, all of us have heard so much about ChatGPT and generative AI. That's a different kind of an AI. That's also an AI, but it's a different kind of an AI that's used for different things. And depending on the use, you would use a different model of AI to be able to get the same outcome. I'm going to move on to the next slide. If anybody has a question, please do feel free to kind of just stop and ask me a question. Okay. All right, so I'm moving on. The use of vision in quality inspection is not new. It has been there for quite a while now. With the advent of use of AI in quality inspection, the computer vision that was used previously was now called traditional vision. And I'll explain the difference to you between traditional vision and AI-based vision shortly. Traditional vision definitely has a lot of applications, and it has significant use cases. But AI vision has actually taken it to the next level. And what traditional vision is that it's basically a rule-based it's a rule-based model. So just think of let's say let's continue using the example of a car, and let's say, hey, there's a quality inspection of a car happening. In traditional vision, over time, more than 1,500 or 2,000 algorithms have already been created, which look at different parts of quality of what the image of a car should look like. And so in traditional vision, you have this rule-based algorithms that are already predefined. And because it's rule-based, you can give, for example, if you want to check the dimension of the number plate each time, on a rule-based system, you give the X and Y coordinates, and you teach the AI there, the algorithm there on what that dimension looks like. And every single time, it will use the same algorithm and will go to measure the dimensions of the number plate and says, yes, it's good, or no, it's not good, right? There is a difference, there's a variation. And from a quality perspective, not good basically means rejected, right? Or to be redone. Okay, now, the good part of traditional is that it's very simple to use. It's very quick to deploy because the algorithm already exists. You just take the algorithm and you implement it. It also uses much less compute power because it's looking for the rule rather than trying to look for many things in one image. Where traditional vision starts struggling is that if there are minor variations in the object that's being looked at, for example, if one of the requirements is that on that number plate, please check if there are any paint flakes, if there are any chips, if there are any stains. You can, through rules, define that a chip has exactly these dimensions, and then the traditional vision will go and look at it and accurately identify it. But if that chip dimension is slightly different, or if the paint dimension is slightly different, or even if the lighting conditions change, traditional vision starts struggling. It is not able to do because there it exceeds the bounds of the rules. Okay, so traditional vision also has another issue where high-speed image capture, inspection, translation, and prediction is a problem. It can do really well if you're just doing things like dimension checks. It can do really well if it's, you're just looking at colors of that particular number plate. It has to be this shade of black, for example. Those kind of things it does really well. But anything beyond that, it starts struggling. Lastly, if you want to make changes to any of the rules, that's time consuming because it's not self-learning all the time. Beyond the rules, it does not learn. That's where AI really starts scoring. AI, you can actually, so for example, again, using the number plate example, AI, you can give a range of shades. AI, you can train it to ignore certain changes in lighting conditions when the image was captured. You can train it and say, hey, this chip or this stain or this paint flake not only happens in this particular way, but it can happen in other particular ways, and the AI model learns. And so the ability of AI to deal with thresholds, the ability of AI to deal with variations is extremely high. And that's why now AI-based quality inspections is really coming to the fore. Okay, let me just pause here. Any questions so far?
Hey, Raj here. Got a couple
Hi,
of
Raj.
questions for you. Is that all
Sure.
right? Thanks for the presentation. You're talking about this. I'm assuming all the AI or the technology you're referring is all based on what your Sunquire is doing. Is that correct?
Yes.
Or it's a general explanation?
Yes, it is. It is based on what Sunquire is doing.
Okay.
But we are
And
not
I'm
the only company there.
No, that's okay. And I'm assuming that these are checked visually using a high resolution camera or something, and then that image is checked at the back end by the different algorithms that you're talking about. Would I be right in making that assumption?
Yes.
Yes, okay. And is this used at the end of the manufacturing process, or you use it as part of your at different stages of manufacturing?
So
Or it's up to you how you want to use it?
it's up to you. But Raj, by the way, this is a really good question. Different requirements do it a little differently. In many and most manufacturing automation requirements we've been through, it's end-of-line testing. There were a couple. One of them I'll talk to you about is it was a wafer manufacturer, a chip manufacturer, and they wanted to do incoming testing for wafers they were getting from their suppliers. And then they wanted to do interim testing at each stage of the chip manufacturing. So it actually depends on the requirement. And in general, and the risk of generalizing also, it depends on the value of the item being produced at the end and the different stages, which will cause a manufacturer to look at not just end-of-line testing, but also interim testing.
Beautiful, thank you.
Yeah, this is Kandamurthy here.
Hi.
Yeah, I was looking at, let's say, an option, like textile sorting, for example, or plastic sorting, where these days, with high-speed machines available, sorting machines available, which can sort at, say, 4 or 5 tons per hour. The time that a textile garment, for example, a T-shirt, if it has to be sorted, the time it gets is the machine would get is about 2 to 3 seconds. Not even that. In some cases, sometimes less than 2 seconds. So when these high-speed images are captured, what do you think? Assumption of about 98% efficiency would be a fair assumption?
Yes, we are very careful about how we state accuracy, because accuracy is something that's built over time by retraining the model. But what we always commit to 100% is repeatability. If we have identified 10, 15, 20 set of defects, and the AI model has picked it up, it will pick it up every single time. Now, as far as the cycle time is concerned, the fastest cycle time that we've had to deliver is 200 milliseconds.
Okay.
This was for a mass, screw manufacturer. And we had to do a 360-degree. Did I answer your question, Mr. Kandamurthy?
Yeah, I do. But, the why I said 2-3 seconds is because, if normal textiles or garments are normally made of, composite polymers, there would be more than one particular polymer. There could be two, sometimes there could be 3-4 polymers as well, like elastane plus cotton plus polyester and whatnot. So when it has to, identify all these components within that time frame? Is it a, I mean, is it a fair assumption to be made that it can do it? That's the question I have.
I think that the cycle time will be a lesser issue than the kind of camera that's being used.
Okay.
The camera and the lighting, I think, will have a bigger bearing on this than the AI time itself.
Okay. Right.
Yeah.
Okay. Understood. Thank you.
I have seen cameras that were able to look at individual fibers also. So, but you know, we haven't done something on polyester material before, so I'm not outright saying things.
Right. Sure. Thank you.
Raj, here again, just follow up on what the previous gentleman asked. If AI is you talked twice about the type of things that AI can pick up. One, in that plate example, you talked about the shades and the painting and whatever.
Yeah.
And here you talked about the polyester and the lighting and the different materials. And you said it can continuously pick up 15 or 16 different types of defects that could come onto the t-shirt as an example.
Yes.
Now, is that defects that has to be input by a human, and then the AI learns it and picks up all the 15? And would it improve on something that a human has left? Or on the worst side, if I want to, as a quality person, I pull out one of those defects out, despite the fact that it is a defect, it will still get out as a product that is defectless, isn't it?
Another very good question. Can I use the next slide to explain this?
Yeah, sure. I'll
Okay,
keep
yeah.
quiet.
No, don't worry about it. No, it's a perfect lead into the next one. Okay. So the way this will work is that which example should I use? So in Thailand, we are solutioning to the second largest manufacturer of side view and rear view mirrors. They have something like 8-10 lines, which produce about 6,000 a day. Okay. And they have 14 defects that they want to us to identify. And those defects include, you know, not just stains and chamfer and grinding and pinholes and spots. They also want us to detect dents and distortions. Dents and distortions are not easy to pick up, because for that you need to tilt the mirror and look at it under different lighting conditions in order to be able to pick that up. The way we went about this, you know, for each defect, we asked the customer to give us 30 samples of what that defect looked like, and 30 good ones, right? So 30 mirrors where the quality manager in the production side said no defects here as far as we are concerned, and then 30 for each defect. And then we took it and we took images of that. So each of those 30 was, we took an image using an industrial camera, and then we did what we call annotate it, which is basically under the AI, we draw a box and say, this is the defect, or this is a feature for the, you know, the AI doesn't care what we call it. For the AI, it's a feature on an object. We call it a defect. So we annotate it, we draw a box around it and say, if you see this, it's a defect. And then we do 30 of those, just so that there are differences in that defect that the AI model learns. Now, the next thing we do is what we call classification. So we classify a pinhole as a pinhole, a chip as a chip, distortion as a distortion, and we teach the AI with each of those 30 defects that, hey, this is a distortion, this is a dent, this is a pinhole, this is a chip. And the AI then understands the classification of these defects, right? Once we have done the training, this is the AI model training, we then take the good ones, the good samples, and we run it. And when the good samples run, if there is a defect, it will pick it up. Okay. If there is no defect, it will say it's good. With the good model, we are also able to do something called anomaly. Let's say we have the 30 good samples. We say this is what perfection looks like. And we train the AI to say, okay, this is a good sample, this is a good sample, this is a good sample. And then we say, now anything that does not look like this, say not good. Even though we may not ask it to classify it into the 14 different defects, right? So then the model runs saying, this is a good defect, this is a good image, or this is an anomaly. Okay, so anomaly is what we use when we want an overall perspective. I'll later be showing you some X-ray inspection images that we did, but there anomaly was also discussed. I'll be showing you a pretzel example. This is something we did in China. This is for the largest manufacturer of fully automated baking lines, including pretzels. There, anomaly is being used, and what happens there is that the customer of that OEM who made that pretzel manufacturing will only pay the OEM for good models done. So every time they will run the anomaly engine as the pretzels are coming off the line. If there is a wrong shape or anomaly detected, we don't pay for it. So anomaly is also used, but anomaly is not recommended for high-speed inspection because there is a lot of data to take in. Yeah. Raj, was I clear about how we do this?
Yeah. Thanks, mate.
Yeah,
Thanks.
Yeah,
Appreciate
we take
it.
images, we annotate it, we classify it, and
Yeah.
then we run the inference engine to get that. Yeah.
No, that's good. That's good. Thank
Okay.
you.
All right. So this is what an inspection ecosystem looks like, right? We, as an AI software company, we do not sell or deploy solutions in isolation. We need to have strong expertise in camera and lighting because a lot of materials require different kinds of lighting in order to make the defects stand out, right? We also work with automation system integrators. These are really important to us because typically we are, deploying our solutions on brownfield, not greenfield requirements, and the quality inspection automation is not already there. So we are kind of retrofitting it back to the automation line that's already there. And there is extensive use of all automation systems, particularly robots, in order to be able to manipulate the object and get a 360 wherever 360 degree view is required. We also use sensors quite a lot. Sensors not just to trigger the image taking, but sensors also in other areas of application. So the inspection ecosystem has a combination of all three: automation, vision, as well as AI. In any line that you have, whether it's a high-speed line or object that needs to be manipulated, from different sides, the first thing that we look at, of course, is the object itself and how many defects there are and what are the defect classes that are there. That's the first thing we look at. The second thing we look at it is if we were to implement, standalone, we are able to manipulate the object and take the images and the camera works fine, the vision works fine, the AI works fine. But the moment you get into automated line, you have to do it on the go. And so there, the number of cameras that you will deploy, the different kinds of lighting that you would deploy, and the automation requirements actually become critical. Also, some customers want rejection systems. Some customers don't want rejection systems. They only want that that particular unit to be highlighted and captured as part of some kind of a dashboard that we're reporting on. So so over time, a company like ours also becomes an expert on vision, though automation is not our forte. And this is particularly important because many solutions cannot be solved by pure AI skill. Many requirements are there that you need to really understand the vision side of the business before you're able to use your AI effectively. So to summarize these two slides, there are three components: automation, the vision part, which is camera and lighting, and last, of course, is the AI. And the AI basically is a combination of software as well as a GPU. In the case of image processing now, GPUs are extensively used. These GPUs, typically most companies are using NVIDIA-based GPUs because they have their CUDA libraries that really help speed up the overall image processing time. So I'm actually now going to move into the use cases and describe some of the use cases to you. Any questions before I move on?
Move on, Subin.
Yeah. Okay. So here are some of the things that we've done for our customers. So what I'm showing here is basically deployments or POCs that we have done already. And by the way, most of these are from India in this particular slide. So the first one really is about how we are able to detect defects on gears. So one of the largest sintered gear manufacturers in India is using a solution. And what we're delivering to them basically is not just measuring the outer inner dias, but also in terms of the gear tooth itself. And the second one, what we're doing basically is measuring all the dimensions that are there. The third one is a Bosch. Sorry, I'm not supposed to say customer. Please erase that from your memory. The third one is basically about measuring the number of ball bearings being put. One of the challenges in manufacturing really is that particularly where robots are not used, and using robots is very expensive. The factory workers, technicians put together a particular part, whether it's a pump or a ball bearing here. One, they're supposed to put a specific number of parts, and those parts are supposed to go in specific places. And in some cases, they need to be put in a particular sequence, right? And so AI is able to actually track all of that and raise the alarm if that's not happening. So Poka-yoke is a very standard feature that's there. In fact, simple Poka-yoke doesn't require AI, but complex Poka-yoke does require AI. Simple Poka-yoke can be done by traditional vision itself. So another piston manufacturer who also was supplying pumps to a Japanese customer had a pump that they were producing. It was not a big volume that they were producing, but those pumps had 3 stages in their manufacturing. In each stage, they had to put specific pins and springs and things like that. And they had an issue where once in a way it was getting missed out with very severe reaction from the Japanese downstream customer. So Poka-yoke or smart object counting, sequence counting, all are things that we do as part of our implementation. The last one here basically is OCR. You will see several examples of OCR as I go through, but OCR is something that is something that AI does really well. Even if the numbers are printed a little out of alignment, it's something that can be picked up. So reading SKUs, reading vehicle number ANPR as we call it, automatic number plate recognition system. These are all standard. Even if you haven't seen it in the manufacturing side, these are things that you will see as part of your daily life. But automotive and general manufacturing is not the only place where we have applications. We have applications in electronics and semiconductor also. So we have worked with PCB manufacturers. We have worked with wafer to chip manufacturers. We've also worked with EV, electric vehicle battery manufacturers. And in each of those cases, they have a specific set of defects. Now, whether it is, a solder splash or a pinhole, or whether the, some particular component has not been put, these are things that we are able to do very easily with as an inspection, irrespective of the speed. Now, from one of the implementations is to check how good the lamination of the wafer is. Are there bubbles? Are there scratches? Are there bulges? From a lamination perspective. And one of the things I need to kind of highlight is that anything that's surface can be detected using an industrial camera. If it's not surface, if you have to go a little deeper, you need to use different imaging techniques, whether you're using X-rays, whether you're using sound, or whether you're using any other form of imaging. As long as that image we can digitize that image and feed it into the AI engine. AI doesn't care what that source is or what format it is in. It look at it and say, yes, I recognize this image. This is a good image, or no, this has the following issues. Yeah. We have also, sorry. We also have significant use cases in the food, beverage, and packaging industry. I guarantee you, at least some of you are eating biscuits inspected by Senquai's Eagle AI. If you guys like chocolate biscuits, this is something we're doing. And this is between 100 to 200,000 chocolate biscuits being produced every single day out of this factory. What do we test for? We test whether the chocolate is oozing out. We test for whether edges are chipped or chips or scratches or deep dents anywhere on the biscuit. We check for whether the baking is correct. And how's the baking checked? The baking level is checked based on the shade or the color of the chocolate biscuit. So if the chocolate biscuit shade is correct, it's passed. If it's not, it's rejected, which means that it wasn't baked properly. So, this is a line of, there are 4 lines of these cookies coming out. There are 4 cameras, and they are operating at a very high speed in order to be able to capture it and then report it. The other one is the world's largest alcohol manufacturer. They have a presence in, I think, one of the world's largest alcohol manufacturers. They have a presence in India.
Yeah,
Hello? All right, I keep going. Please interrupt me if you have a question. So, he asked if it's McDowell. No, it's not McDowell. Sorry, I didn't hear that properly. We, in general, manufacturing companies are really, really particular about us not using their name or us not sharing. We have to sign NDAs, very stringent NDAs with all of them. That's why I'm being careful not to mention names. So if a name slips out now and then, please ignore it. So here, what we check for a few things. One, is the labeling correct? Number 2, is the liquid fill level right? Number 3, before the bottle comes out, this is actually a glass bottle. They're moving to PET bottles now. Is the top okay? Is the threading around the bottle okay? So there are a number of defects that are checked for when we do this. Similarly, a very large packaging material company wants us to do the counts on the number of folds of the packaging material. So they produce the packaging material, which are sheets of some polyester or some such material. And they have about 100 different products. But of course, when they do a run of one product. But each of them have different number of folds, and each of them have a different color. Now, the challenge we have there is that some of the colors are very dark, And it's very difficult to look at dark shades without the kind of right lighting. So we're using a combination of blue and red lighting in order to be able to be able to accurately do that. So lighting is also really important because lighting solves many problems that that defeats the lens of an industrial camera. Okay. For the same biscuit manufacturer, we are now working on a new project where they want to be able to ensure that they have a biscuit and the biscuit has got, it's a sandwich, it's got holes. Has that hole been filled with cream or not? That's all they want to do, because if that biscuit, for some reason in the manufacturing process, that cream is missed out, that's a downstream issue for them in terms of customer satisfaction. And so they want to make sure that they have that. So fill levels is the other thing that we test. Okay. I'll skip this particular example, but I just want to tell you that we have international customers who are doing N95 mask inspections as well as swab inspections. Okay. So there is a high amount of what you see here is a Continental tire on your this was not a project we did for Continental, so I just want to correct that straight away. This was for one of the largest tire manufacturers in India. Each of that tire, this is a company that's really particular about quality and also very, very strict about their trade secret. So each of the tires has got, an X-ray image taken to ensure that the quality of the tire is okay. They have 2-3 different kinds of defects. Basically around spreading of the cords, spacing of the cords. And an X-ray image comes with a resolution of 2,400 by 11,000 something. I don't remember the exact number. Now, to ingest such a large, heavily pixelated image in, and then figure out a very tiny defect on it. So what you see here actually is the full tire. So when the X-ray machine takes the image, it takes a full image and then it stretches that out, completely. And so then the AI engine needs to run over that entire length and then figure out very small defects that could downstream lead to dangerous situation for the customers of this tire manufacturer. This is a really difficult model to do because this is called small object identification. To find 8 pixels in 2,400 by 11,000 pixel image requires a lot of work. But today AI models are there that are able to do it. The right side of this actually is, if you look at it, on the top right corner, what we have is a normal image of a car. Then we use photoreflective processes, and we convert that image differently. And what this allows us is to be able to read black on black, right? Because tires are embossed with the name of the company, the name of the tire, the product number, and a part number. And some of them are very light steel embossments that are there. And so to be able to pick this up, this is more the capability on the lighting side than it's on the AI side. The AI is able to, once the lighting does its magic, AI is able to read this very, very quickly. Now, I have really taken a lot of time on this. I just want to check on time. How much time do we have, Gopi?
Yes, you have another half an hour.
Okay. Okay, so I'm going to stop on quality inspection. I just want to say that, companies like Senquire are really not looking at quality inspection as standalone, right? Quality inspection will become really powerful when it becomes closed loop, which is under what conditions were those did those defects occur, and how do we eliminate them? And that basically is not just AI, but it's the ability of AI to take data from IoTs, from all the machines, a machine language coming in, and then becoming, first of all, descriptive, from descriptive, moving to analytical, from analytical, doing predictive, and finally prescriptive. Basically, what this is we are able to analyze, we're able to tell what defects are there, but with a lot more information coming in and the AI becoming smarter and smarter, it will be able to say what the manufacturing unit should do, first of all, to eliminate those conditions. And if those conditions occur, what's the immediate preventive action to be taken? So that's the direction. It's not just Senquire, but most of the leading machine vision, AI machine vision companies want to be able to support Industry 4.0, want to be able to support the autonomous manufacturing process that some industries will require.
I have a question.
Yeah.
Have you done AI implementation in any footwear industry in manufacturing?
No, not to my knowledge. I
Okay.
can check, but not to my knowledge.
Okay. And the second question is, typically, what is the cost of implementing AI versus the payback? A company doesn't have the system and implements it, and typically, how long does it take to recover?
So most of our customers in India will not entertain us if the payback is more than 4 years.
Okay.
We can very comfortably deliver 4 or less. The issue really is two things. One is the complexity of the AI model that drives up the cost. The other is the automation to support the QC. The more fancy and more automated it is, that also drives up the cost. The AI by itself is not the expensive.
The third question is, if it is a particular industry like footwear manufacturing, for the industry as a whole, would you do a study and give a report on where AI can be implemented and where it can be of maximum use?
I'll have to check. Yeah.
Customer contracts.
We are a small company, we're a startup, so resources is always a constraint. But there is no customer who has bought from us without a POC being done.
Okay.
So, rather than broadly industry, report being generated, if there is a specific customer in the leather industry who's willing to give us either a paid or unpaid POC, but with the intent of implementing it, I think a company like Senquire would be more than happy, or there would be other companies also willing to do it. Sorry, who asked this question?
My name is Ramesh Subramanian.
Okay, I was just trying to understand who asked this question. Shall we move on there?
Yeah, please go on.
Okay,
Can I just ask you one question, Mr. Subin?
Yeah.
Before we move away into the other subjects, I mean, the quality side, there are a number of companies who talk about the Six Sigma process, business process, basically.
Yeah.
And then they claim that they could have, not necessarily they have done 3.4 defects per million and so on, but very close to that they do sort of claim. But does AI really, have you worked with any company like that to show really they are achieving that Six Sigma quality?
No, at this stage in our journey, we have not.
How old is your company? I mean, you've been just about there for
2 years. I've been there for 2 years. Yeah.
That's good. But already I think I've seen that you've worked out a number of applications and then multiple products. So obviously you're into that.
I'll be honest with you, AI is such a catchy subject. There are many customers who pull us in for curiosity rather than a real need. And in many cases, we do agree because, at the end of the day, the more number of use cases you have, the better it is in terms of your ability to address different needs. So in many cases, we agree. But, our focus is mostly automotive, semicon, food and packaging, food, beverage and packaging. That's why
Textiles also?
we haven't had a specific textiles requirement, but as I said, I would love to be able to talk about it and understand it better.
Thank you.
Yeah.
I have a question.
Yeah, sure.
Actually, for the quality control, you are training lots of data, very big data. But you get the only defect data is very, very less. Then how do you train the model to fit and analyze the defects? Because the defect data is very, very less. How do you manage that case?
This is one of the biggest challenges that customers face in terms of being able to give us defect data, because historically, um, the capturing of data and storage of data has not been
Baba, your tongue can
has not been done as well. So typically, this is where we struggle in terms of being able to help our customers, or our customers also struggle to give us the data. And sometimes it takes, an agreement between us and the customer, and we monitor, or they monitor their site for defects for 3 months or more, and then they give us a pool of data that we can use. So what you asked is actually one of the key pain points of implementing this. I hope I answered your question.
Yeah, thank you.
Can I come in for a minute, please?
Sure.
Yeah. No, I was just wondering whether you do these positive disruption tests or something to understand, like, in the plastic industry, when you do testing for PET bottles or something,
Yeah.
You don't get a defect. But what happens is the testing lab, deliberately puts in, let's say, 10 ppb of some benzene or, toluene or whatever to, create a situation of defect, and then, test it to see if it's able to find out. Something like that. Can something like that be done? Because I'm talking from a textile sorting point of view, where, textile sorting is as old as your company, so to say. It's just 2-3 years old now. People are looking at textile waste sorting because of climate change and other issues. So is there a possibility for a study to be done that way, by injecting some,
Why,
purpose?
I mean, if I can
A
get
lab study. I mean, a lab study.
I'd like to understand a bit more about it. If there's some way we can
do
catch
that
up later.
offline also,
Yeah,
not a
yeah,
problem.
yeah.
I mean,
We can do it
taking
offline then.
so many people. Yeah. I mean, I get your contacts, and then we can discuss
Yeah.
this.
Yeah. Thank you. So we spoke about quality and inspection and how machine vision is being used there. But there are lots of application of machine vision for manufacturing outside of quality also. And one other area where we as a company deliver solutions is related to safety, security, and surveillance. Some parts of this are fairly straightforward and self-explanatory. Some parts I will explain. So, in any manufacturing side, they have protocols already put in place in terms of how they will manage in the event of a fire. Many manufacturing units already have sprinkler systems in place to take care of that. Where we come from, or where AI comes in, is basically if you have to deploy the sprinkler system, your factory will will need to get shut down for a certain period of time before you can actually bring it back operational again. So what AI is able to do is AI is able to track smoke. So even before or even a spark, and based on the pattern, it recognizes the pattern of movement of the smoke. It recognizes the spark, the behavior of the spark, and then it calls out and it very clearly and says, "Hey, here's a spark." And then, depending on the protocol that's said, it will send a message, WhatsApp, or an email, or an alert, or it'll ring a bell, or set off a bunch of lights. So AI is really useful because it can catch things at a very early stage where you don't need to deploy your reactive systems into place, where you can address it a little differently. The other one, of course, is vehicle monitoring, and I'll show you how vehicle monitoring is done. I'll show you a video, which will kind of be very self-explanatory. Vehicle monitoring is not just number plate recognition, but also is the vehicle behaving according to the rules assigned for that zone. Now, The example I'll show you is on a highway, but you could think of it as AGVs moving on a particular factory floor, or any other vehicles moving on aisles in a factory, and the ability to be able to monitor the behavior. The last two is about unintended object detection. Imagine a hospital. You don't want a bunch of stretchers blocking out the entrance to the emergency, for example. Or it could be any other kind of object that should not be there, or an object that should be there but is not there. So all of these are things that AI can monitor and give an alert of. Last but not the least is, PPE, right? Your personal protective equipment. Are the hard hats in place? Is the suit in place? Are the goggles in place? Is the goggle in there but not on the eyes? Is it somewhere low? Is the mask in the right place? All of these things related to factory and worker health and safety, all the EHS requirements are definitely done. We have an implementation of a combination of these things, where in a very large semicon company, they have these two huge 6-axis robots that are taking the wafer plates from one place to another, moving extremely fast. But it's a class 100 site, which is near 100 or near autonomous. But they do run into issues, so workers need to step in, or somebody will stick a hand and just try to tap here and there to keep things moving. And that's a safety issue. And so we have deployed an AI system there that will, the moment a person enters, the PLC sends a signal to the robo, and the robo stops. Then, till that person is there, the robo will not start. Once the person leaves, it will wait for a cool down period of 1 minute, and then it'll let the robo start again. Now, all of this is not being done through fancy cameras. These are regular CCTV cameras that are deployed there. So each of these things, right, on detection of people, vehicles, fire, smoke, is using regular CCTV cameras to be able to detect. So this is a case study on smoke. So let me see if the video will work. I hope the video works. So this is one of the largest publishers in India. They wanted to know whether their electrical, where the electrical junction boxes all over the place, whether it would be detected. You can see this here. A match lit also is getting detected. This is not rocket science. I'm just giving this as an example. So it's able to distinguish the difference between a flame from a matchstick, these red lights, and some of these orange lights also. So it doesn't highlight those as okay. This is an example of smoke. If you look at the top, let's see if the video is working. So it sends the smoke, it's zoomed in, and it sends an alert out saying, hey, there is smoke here. This was done in our development center. Sorry, I hope to get a really good video out of one of the largest waste management plants that we are implementing fire and smoke detection in India. But right now, the videos are more demonstrative and lab. Okay. So this is on PPE. Are the people wearing hard hats? So this person is wearing a hard hat. There is no alert. The next person walks in, no hard hat. And if you look at the top right corner, it says new event detected. It'll take the photograph. So the system will also keep track of how many such incidences occurred and what time they occurred, and keep a digital copy of it. Okay. So this is the full PPE standards. I don't have a video here, but we have, as I mentioned, the site that I mentioned earlier about the wafer manufacturer. We are checking for caps, we're checking for the full PPE gear. We're checking for gloves. We're checking for eyeglasses, and we're checking for face masks. And they have their own protocol in terms of how they want to be notified. They have to be a little careful because the moment you start monitoring these things, the workers' union do get a little excited. So it has to be navigated around a little bit. Okay, this is perimeter breach. So in AI, I told you annotate object, which is basically you draw a box. So that's called a bounding box. The other thing also is like a bounding box. It's called a region of protection. So on this image on the right side, you can see a glass door there. You'll see a person walk in and walk out, and we will detect that person at any point of time. Again, what this basically does is that it takes naked or dumb CCTV cameras and makes them smart. And if there's a large installation of cameras in any manufacturing site or a commercial building, implementing a full smart CCTV, some CCTV cameras come with AI chip on it or a GPU on it. That becomes very expensive. Here you can use just a simple CCTV, and on the back end you have this monitoring that happens. So this is another example. I'll just go to the last one, which is, so this is from unintended object as well as vehicle monitoring example. So you see this vehicle going, it's got a plastic ball behind it, the ball falls off. It's monitoring, by the way, it's also monitoring the speed. On the right side, it finds the object is there, it raises the alert. The vehicle is going away, and now the vehicle turns around. Now the vehicle is turning around and it's coming in the wrong direction. So then the AI says, hey, this is a new issue here. Now it's entering that region of protection. So the moment it enters that region of protection, AI, yes, there it goes. So it enters the region of protection, and so it signals, hey, this vehicle is going the wrong way. Okay. Actually, this person is being very kind, coming back and picking up their fallen object, not leaving it lying there. But they're not supposed to be people there. So it picks up and says, hey, there's a fallen object, and there is a person also who stepped out of the vehicle, which is not supposed to happen. So, you can teach the AI what is okay and what is not okay, and the AI will always be able to do that. The strength of AI is that it's able to take variations of that. So it's not just strictly one way. You can teach AI to look at things a little differently. If the same issue happens in a different part of the object being inspected, it will pick it up. If the shape, dimension, and color is slightly different, it will pick it up. At the very least, using anomaly model, it will say, this is not what good looks like. There is something wrong here. Something needs to be done. So this is what I had from a presentation point of view. I want to stop and ask if there are any questions.
Thank you very much, Subin. We'll keep the floor open for question and answers now. Yeah, participants, you may please ask your questions, please. Yeah, SRS, please go on.
Yeah, Subin, very nice presentation. I have a question. You mentioned about robot cell, where they are monitoring the safety of a person entering the cell. In fact, I work for a company, we are global leaders in safety, but we have different type of sensors that is certified for some safety levels. They call it as performance level or category level or SIL level. So do you have any certification in that space?
So this is one of the things that we are applying for. We actually have a European customer who wants us to apply for this and make sure that we get it. So it's high on the agenda, but a quick short answer is not as yet.
Okay. Okay, and another question. Can you use multiple cameras to monitor this type of like road monitoring? You know, it will be in kilometers, you know, but how do
Yes.
you manage those type of multiple cameras?
The camera feed actually goes into a network switch, and it goes to a graphics processing unit. Typically, depending on the kind of image, a single graphics processing unit can handle up to 20, but it kind of varies with the conditions. 20, 25 can be done. So the example of the road I gave you, the road is a 70-kilometer stretch, and it's for 140 cameras, which are positioned so that there is no blind spot, and so the field of views are all managed. So that's the extent to which we have tested. But multiple cameras is definitely something that most customers require.
Okay, thank you.
Yeah, that was a great presentation. Thank you. It's very insightful and a lot of knowledge, new knowledge, so to say. I had another question. I mean, do you have any experience or exposure to NIR sensors, and do you have any, ideas on how good they are when compared to RGB cameras or something? I mean, I'm talking of material detection in terms of.
May I know who's asking the question?
Kandamurthy.
Mr. Kandamurthy, I will get you the answer. I myself don't know, but we have a development center and some really smart engineers there. So your question basically is NIR, huh?
Right.
NIR versus RGB. Okay, I'll get you the answer. Yeah.
Yeah, sure. Because what I heard is NIR in terms of categorization of material types is better. I mean, I'm not sure, from the supplier. So I'm not sure. I've not had good experience. I mean, I've not had not good experience. I don't have much experience in that. So I thought, to share some insights on that.
For sure, I'll get you. If I can get any documentation on this, I'll get it. Otherwise, I'll get you. I'll let you know what the team says. Yeah.
Yeah, sure. Thank you so much. Thank you.
Yes, sir. Go on, sir. Ravindra, sir. Please go on, sir.
Yeah. Mr. Subin, I think it's an excellent presentation to give you an overview of how AI could be applied in various for defects and so on, and also the safety part, what you covered last one. I just got one question, like in the manufacturing industry or engineering designs, what we do. I'm ex-Larsen & Toubro, so we have used a lot of these metrics. I mean, the standard, well-defined metrics to test the software or the actual product that's done. But the algorithms, what you are developing for AI, they are going to be also testing out a defect. I mean, where already well-defined matrix has been done for our methods which we have chosen. Do we have a similar kind of any measurement matrix for your algorithms? The reliability of that I'm talking about.
Good question. I don't have an answer, sir, but I can find out.
Very important, because what I understand is AI has got limitations, and it can pose some risks, especially when you're using for a very high level manufacturing defects and so on. I mean, it may just well pass through because it's not being given the right kind of a metrics for that. So we have gone through this, of course, over a period of time in oil and gas industry. I myself have contributed to that. So my only thing is, I think when you're getting into a little more complicated products, I think the tire is definitely is a complex one, but it's just a single piece. But then you have a very complex machinery or a plant, if you want to go into that, which is going to be futuristic. AI is going to have many, many applications in that as well.
Yeah.
So this would be a good idea to look into. Someone told me that there is something like a Turing test. I mean, Turing test is anything will pass, I understand. I mean, it's not a big thing.
I think what you're asking is a little more than that, right?
Yeah, much more than that. Okay, I think just a thought for you then.
No, thank you. Very good feedback.
Hi, this is Arvind here. I have a couple of questions to you. As you said, based on the object of interest, which is needs to be detected using your vision based. So the selection of cameras, as you said, is like a CCTV camera that comes for an object of interest, which is of large size. But when it comes to the smaller objects, as you said, like in PCB industries, we have been doing a couple of things. So what type of cameras do you select? Is it like any specific manufacturers?
So there are many manufacturers of industrial cameras. The popular ones are a couple of German brands, Basler and Bommer. You have Omron that makes cameras. Then you have many others also. You have Chinese brands also that make cameras. CCTVs, of course. Similarly, the China brands are a lot more prevalent, though I think India is now catching up very quickly on that one. But we generally tend to use either Bachelor, Bomber, or Omron.
Okay. The second question is like actually when you define your training model for AI based on the field of view of information. Okay. So you define your training model based on the objects what needs to be detected. Okay. For example, in a manufacturing industry where I'm basically in an electronics industry, so on a defined field of view area, probably we define that two or three are the areas which needs to be identified, but sometimes there is a use cases which comes that a foreign object, apart from whatever is there, what should not be detected. The negative logic of actually identifying anything else which is coming up in the field of view area. Is there any training model can be done on that? Because generally these models comes only for the specific object of interest which we do. But sometimes there are use cases which comes that apart from the training model, any other foreign object also comes as an institution or an object to the field of view that also needs to be detected. How is that categorized?
Um, so that's by the way that's something that is asked for quite often. So detecting something that should not be there, again, it's an anomaly, right?
Yeah.
So if it's an anomaly, it can be detected and it can be reported. Now, if you want to give an anomaly a name, then you need to train the model. You say there are water droplets here which should not be here. And then it recognizes, okay, now from unknown unintended object, it becomes a known defect that needs to be checked.
Okay.
Did I answer your question?
Yeah, probably, yeah, anomaly is one aspect of it, but yeah, but as I said, like a foreign object which is not defined in the training model at all. So, people would like to have a proof of concept that any object apart from what is being there should be identified. It can be a small hair, it can be a shoulder ball, it can be anything. So that needs to be identified. So something.
So one of the largest friction plate clutch manufacturers in the world, and they have a factory in Chennai. They wanted us to check whether the threading on the friction plates is done properly. That was one of the things that they wanted to check. But when they were doing the threading, once in a way, a burl would pop up, right? Just a piece of threading. For them, from their perspective, it's not a defect, but for the AI, they say, hey, that's not supposed to be there. That's a defect. So then we trained the AI model to recognize that burl as a defect, as a not as a defect. The next thing that happened is that the dust conditions were really high, and there were some large dust mites that were coming, and they were getting recognized again there as potential defects. So small things like dust mites, hair, as long as the camera can capture it, the combination of camera, lighting, the angle, and the camera can see it, it can be identified and say that this is not supposed to be. I don't know what this is, but it's not supposed to be.
Okay, thank you. You have your design center or your R&D center in India, or is it
Pune.
elsewhere?
Pune. It's in Pune.
Okay, great. Yeah. Okay.
Please unmute and ask your questions, please.
Sir, this is Rajendra Sapre.
Hello.
So, yeah, there are two questions. Number one is that the lighting plays very crucial role. So, is that more of an art, or is there like a documented or something like that? I mean, some kind of heuristics on the selection of lighting for a specific problem?
It's an absolute science, sir.
Mm-hmm.
There is no art to it. It's an absolute science. It just needs to be applied correctly.
Okay.
For most manufacturing uses, lighting is necessary, but it's not critical. But if you have defects that will not show up unless the lighting angle changes or you kill the object, that's where the lighting becomes critical. Secondly, there are some defects that will not show under normal yellow light. You need to change the lighting, or you need pattern lighting to be able to kind of see the defects. That's where it becomes critical. But as I said, it's not an art, so it's a science.
Okay, great. Thank you. And did you do any, I mean, any place where you need to do some kind of multiple cameras or kind of stereo vision in order to detect the quality?
The number of cameras is determined by both the number of defects, the type of defects, and the speed, and the speed as in the cycle time required. The maximum number of cameras that we have implemented so far is 7.
Okay, so
7,
where the
yeah.
decision comes from the combination of image processing from all, that means.
Correct.
Okay, great.
Correct.
Wonderful.
Yes.
Yeah. And you mentioned about the specialized stuff like GPUs and all. So are they really useful for training purpose, or would they be needed even for the production, means for the real time analysis?
They are not really required for training, but for production, because of the cycle times in general, GPUs are preferred, sir.
Achha, for cycle time requirement. Otherwise, they are not needed actually.
No, yeah, it depends. So some companies have implemented their entire requirement, I mean, entire solution on a particular GPU. In Senquire, we have, our deployments are always done with NVIDIA GPU, but we have a training model which is on the cloud where you can use your notebook to kind of train the model yourself.
Okay, okay, got it. Got it. Thank you.
Participants, you may please unmute and ask your questions.
Yeah, I have one more question. In our applications, we have come across suppliers who say augmented reality based vision systems are better compared to AI. Do you have any references, or is the technology of AI based is better compared to augmented reality?
Sir, augmented reality is not definitive, sir.
Okay.
I'll tell you what I'll do, right? Rather than me, I'm a AI machine vision company, and you're asking me whether I'm better than augmented reality, right? So I don't want to get it.
I'm
what
just
I'll
a
do,
user,
sir,
so I need to understand. Yeah.
Yeah. If you can share your email ID, I'll send you a white
I'll do
paper
it.
on that, sir.
Sure.
Yeah.
Sure. You do it.
Okay.
Yeah.
Balaji Lognathan.
Sir, I was just observing, and it's very inspiring to see this. There is, I got connected with Mr. Subin via LinkedIn, and we're looking forward to see how we can collaborate, sir. It's a very nice session.
Thank you. Thank you.